Good day, everyone. I am Cadet Hyacinth Sanchez, and this video will be about the two instruments used to measure the speed of the ship. We have the electromagnetic log and the Doppler log. On board a ship, we can use both the electromagnetic log and the Doppler log to measure the speed of the ship. The difference between the two is that the Doppler log has the ability to measure both speed through water and speed over ground, while the EM log can only measure the speed through water. To give you an overview of the electromagnetic log, it is composed of a sensor, which is also known as the measuring rod, an amplifier, a speed transmitter, and an indicator. The sensor is usually surrounded by a magnetic field, which is attached to the tip of the measuring rod. It sticks out from the bottom of the ship into the sea. The relative movement of the seawater, in contrast to the magnetic field, produces voltage, which is measured to determine the speed of the ship. This also gives more accurate speed indications at slower ahead and astern. The sensor comes through into the sea, reduces the influence by the ship's wake. The ship's wake is a result of turbulent flow of water over the hull and propeller, and it enables more accurate measurement. On the other hand, the sensor is still at risk of colliding with obstacles like driftwood. As a result, the latest EM log is flat, and the sensor does not stick out from the hull bottom. Here, it shows an example of an EM log with an orthogonal bidirectional sensor. It can measure the movement speeds from fore, aft, port, and starboard. The tip of this device has an electrode inside, which is coil, and an amplifier that generates a magnetic field. The length of the sensor that comes through from the whole bottom varies by model, but normally it ranges between 7 and 50 millimeters. The whole bottom is fitted with a watertight sea valve since the EM log is used with its sensor being exposed to the seawater. When we are changing sensors, the sea valve must be handled carefully and properly in order to prevent seawater ingress. Next off is the performance of the EM log's measuring rod, which is determined by a ship's whole bottom shape and the installation of the position of the rod. Such measuring rod must be adjusted to match the unique characteristics of each ship. We have different adjustment items for the EM log, which consists of 0-point adjustment, span adjustment, and sensitivity adjustment. First is the 0-point adjustment, which is conducted when the 0 point of the sensor has changed or replaced. This adjustment is made when the speed of the ship is 0, which means the ship is at anchor. Next, we have the span adjustment. It is necessary when the log speed is misreported due to fouling of the ship's hull. Lastly, the sensitivity adjustment. It is necessary when the measured value changes due to the difference in sensor sensitivity, such as when the sensor has been replaced. Reminder that before making such necessary adjustments, read the operating manuals. The EM log does not require regular or daily checks unless a trouble occurs. On the other hand, when in dry dock, care must always be taken in order to prevent damaging the sensors. It is necessary to have regular cleaning, especially the need to remove scale and oyster shells from the sensor. To give you an overview of the Doppler sonar speed log, it launches a supersonic wave into the sea and uses the reflected signal from suspended matter. It has the ability to calculate the speed by detecting the Doppler shift of the reflected signal. The Doppler log has two modes. The first one can measure the speed through water, and the second one can measure the speed over ground. It consists of a transducer that transmits the supersonic wave, the transmitter receiver, and the main display. The transducer is located at the bottom of the ship with an oscillator installed at its end. The ultrasound signal is launched in two directions, towards the bow and towards the stern. This is known as the dual beam method. This method has made it possible to importantly reduce the error margin due to vibration from rolling and pitching. The error margin of the measurement of the speed due to trim changes accurate speed measurement, especially in rough seas, has been reached. Currently, it is already possible to make the transducer small enough to fit in the bow. It will be less subject to the effects of bubbles in the seawater. The main body is composed of the display unit and operational unit, which switches the display and conducts various measurements. The cursor pad or trackball in the operational unit is used to select the menu. The menu button is used to open the main menu and to stop the operation. Speed through water is the speed of the ship relative to the seawater within 3 meters of the hull bottom. The speed over ground can be measured up to a depth of about 200 meters. Take note that speed can be measured to an accuracy of 0.1 knots if there is at least 1 meter clearance above the seabed. Due to its nature, it is effective for speed control when berthing or for making a decision on the timing of anchoring, because the measure of speed is highly accurate. However, Doppler sonar speed log accuracy is susceptible to waves during rough weather and bubbles generated when the ship goes astern. Additionally, the speed error can be caused by noise interference, etc. Precautions must be taken when in dry dock. This includes turning off the power supply, ensuring the transducer is not lowered onto the docking keel blocks, removing crustaceans, etc., adhering to the surface of the transducer. Lastly, ensuring that the surface of the transducer is not painted. Both the EM log and the Doppler log are important instruments for navigation. The EM log is used for measuring speed at low speeds and for checking the accuracy of the Doppler log. The Doppler log is used for measuring speed at high speeds and for measuring the speed over ground.